Alright, so in one process, 124 grams of aluminum are reacted with 609 grams of Fe2O3. Okay, and this is a balance equation. We need to find out the mass of Al2O3 formed. So what we need to do, first grams of aluminum, we convert moles of aluminum, and then using mole ratio we convert moles of Fe2O3 needed, and then we can find out grams of Fe2O3 needed, or we can do other process where grams of Fe2O3 given, you convert moles of Fe2O3. Using the mole ratio, you calculate moles of aluminum needed, and then you convert to grams of aluminum needed. So that's the first thing we need to do, and based on that we can determine which one is a limiting one. Alright? So we are going to start with this one, this equation. We are going to start with grams of aluminum one. In here we have given 124 grams of aluminum. So first we convert into moles of aluminum, and then using mole ratio we can use moles of Fe2O3 and then convert into grams of Fe2O3 needed for that process. Alright, so let's start with 124 grams to the moles of aluminum. I'm going to go to next slide. We have 124 grams of aluminum. We convert into moles of aluminum. So 1 mole of aluminum divided by 27.0 grams of aluminum. So that's how we convert grams of aluminum to moles of aluminum. Now remember, using the balance equation, we know that 1 mole Fe2O3 is reacted with 2 mole of aluminum. That's the mole ratio from the balance equation. This mole ratio you can find. The reason we are doing it, so we convert moles of aluminum to moles of Fe2O3. Now we need to convert moles of Fe2O3 to grams of Fe2O3. So we know that 1 mole of Fe2O3 and which is 160 grams of Fe2O3. That's the molar mass. 160 grams is the molar mass of Fe2O3. While doing that, you get moles of Fe2O3 cancels and you get grams of Fe2O3. While you calculate, you get 367 grams of Fe2O3. Alright, so you start with 124 grams of aluminum and you need 367 grams of Fe2O3. Right? But what is given here? 601 grams. Right? This is the needed one. But what is given? 601 grams of Fe2O3. So that's a given. So while looking at this data, you can tell aluminum is limiting reagent. Right? Because while working with aluminum, 124 grams, you only need 367 grams of Fe2O3. We have given 601 gram of Fe2O3, right? Now, using this limiting reactant, we need to calculate amount of the product that's being formed. Alright, so let's go to next one. Let's say we have, so use limiting reagent. In this case we have aluminum. To calculate amount of product that can be formed. Okay, so we have given grams of aluminum. We convert moles of aluminum, and using mole ratio we convert moles of Al2O3, and then we convert grams of Al2O3, because only limiting reagent, right? Because we have 2 moles of aluminum, Fe2O3. This is our balance equation, Al2O3 and 2 moles of Fe. Now we have given, now we are applying this one here, 124 grams of aluminum. We convert, let me rewrite aluminum symbol again. We convert into moles of aluminum. 1 mole of aluminum, it's 27 grams of aluminum, multiplied by mole ratio. We know that 1 mole Al2O3, and it's used up 2 moles of aluminum. That's the mole ratio from this balance equation. Multiply 102 grams of Al2O3. That's the molar mass of Al2O3, which gives 1 mole of Al2O3. So when you check that grams of aluminium, we convert moles of aluminium. Using the mole ratio, you come up with mole of Al2O3 and moles to the gram of Al2O3. When you calculate, you get 234 grams of Al2O3 produced. So based on the limiting reagent, you can find out the amount of Al2O3 you can produce.